is question 49, chapter 9 in our physics textbook. And the question asks if we have a 200-gram ball and we're dropping it from a height of 2.0 meters and it bounces off the floor and rebounds to a height of 1.5 meters. The question is, what is the maximum force exerted by the floor on the ball? So to solve this problem, there's a couple things we have to solve for first. The first thing being the velocity when the ball is dropped before the rebound, and then the velocity after the rebound. So to do this, we have to use these equations here, which is velocity equals the square root of 2 times the acceleration of gravity times the height. And since we have two different heights and two different velocities we need to do it twice using like v1 and the first height, which is the height before the rebound, and then v2, which will be our velocity after the rebound, and h2, which is our rebound height of 1.5. So once we have indicated which one we need, we just plug the information that we have into this equation. So like we said before, v1 will be our velocity before the rebound. So v1 equals the square root of 2 times acceleration of gravity, which is 9.8 meters per second squared, times by the height, which before the rebound is 2.0 meters. So once we run this through our calculation, we get v1 equals 6.26 meters per second. And the reason why we'll give it a negative sign here is because velocity is a vector, so it has both direction and magnitude, and since the velocity is going downward towards the floor, we can give it a negative sign indicating its direction. And then we do the same thing for the second velocity. We use the same equation, but instead of our initial height, we'll put in the height after the rebound. So we get v2 equals the square root of 2 times 9.8, which is the acceleration of gravity, times by 1.5, which is our rebound height, which will give us 5.42 meters per second, which is our velocity after the rebound. So once we have our two velocities, we go back to our original question, which is the maximum force exerted by the floor to the ball. So to use what we have derived and to get that final question solved, what we need to do is use another formula and derive an equation that can fit that question. So to do this, we start with this equation here. I equals the mass times the like v2 minus v1, but we don't have impulse. So what we can use instead is, in the problem, there was a figure given to us that showed the impulse, basically the force over time of like the ball rebounding. So what we can do instead to get to something that we can actually use to solve for the maximum force, we know that I is also equal to the area of this triangle here. So to get that area, we can use 1/2 times by the time it took, times by the maximum force, as this graph is force over time. And so once we set everything to solve for our maximum force, we get our maximum force equals the mass times by v2 minus v1 over 1/2 times time, which once we input the information we have into this equation, we should get our maximum force. So for our mass, we can use the mass of the ball, which is originally in 200 grams, but we need it in kilograms in order to cancel units. So we change 200 grams to kilograms, which gives us 0.2 kilograms. We input that into our equation. We also input our velocities that we calculated, and our v2 is the 5.42 meters per second. Our v1 is the negative 6.26 meters per second, but because you're minusing a negative value, you basically add it to the 5.42, and then this is all over 1/2 times the time. Now to get the time, it actually provides it in our figure provided in the problem. which has it in 5 milliseconds. To get it to seconds, we just need to divide it by 1,000, which gives us 0.005 seconds. And so now that we have all the information we need in our problem to solve for the maximum force, we just run it through calculation, and we get our maximum force equals 934.65 kilograms times by meters per second squared, which is equivalent to 934.65 newtons. And that's the answer to our question of what is the maximum force the floor exerts on the ball, and that's how you do this problem.